So then, can I ask you this, because you have a more traditional trained formal background, but you would have seen in the last 20 years the inclusiveness that technology has with people from non-traditional backgrounds. What do you think are the challenges that people with non-traditional backgrounds, non-computer science formal education, what are the challenges that they face when they enter engineering roles? We talk about people who are self-taught or from boot camps. What are the challenges that you see that they have?
Number one challenge that they face is this self-doubts. They enter, let's say they take a boot camp, they get a job. Now they start working for a company and they see all the computer science, all the people with computer science background around themselves, and they think, oh, these guys are experts, they are pros, and I need to catch up a lot. But I think that's not the correct way of thinking about it, because then you almost feel inferior. And see, if you want to become a successful programmer, you need to have some raw skills, your analytical abilities, your curiosity, how well you can analyze a business problem. All of these things are required for becoming a good software engineer. People think, no, you need to know just coding and computer science, but there is a lot more that you need to know. And maybe the kind of background that you're coming from, let's say your case, you were a lawyer for so many years, you come from this background where you need to think about all this if analysis, right? Like, okay, if my other lawyer argues about this thing, what am I going to answer? What will be my answer? So it's like almost like a game of chess. You think about all the permutation combination. Coding is like that.
Yeah.
Okay, if this condition is false, or if this scenario occurs, how my program is going to behave. So when you join, let's say, Google, you have this unique advantage with your lawyer background. And people often, they don't give enough value to that background. They think, okay, I'm starting from point zero, and now I need to learn everything else. So that's number one thing, which is like a lack of doubt that they face, and that creates a lot of other challenges. And the other challenge that I see them face is, I have seen boot camps where they teach you Java or Python. It's an accelerated program, which you, let's say, boot camp that you do for 3 months, and they give you a certificate, you somehow get a job. But what you lack there is a knowledge of, data structures probably, or computer architecture, let's say, or operating system. And I've seen this, like a lot of college kids, they focus so much on competitive coding that they don't pay enough attention to computer architecture and those basic principles of computer science. And when you ask them, okay, do you know how the program is going to behave in terms of your memory growth and performance, and you think about the scalability and things like that, they don't have a good understanding of those ideas. So I would say just learning Python and Java is not enough. Like, you need to have sound fundamentals of computer architecture, computer science, data structures, algorithm, the bigger complexity. So if they have not spent enough time on those areas, then they will run into a lot of problems, where in bootcamp you have written this dummy program, but when you start working for a company, you are going to deploy this program, which will be used by millions of users.
Absolutely. Yeah, no, that's, it's really interesting you say that, because I came very close. I, in fact, went to the US. I was in San Francisco and enrolled in the bootcamp. And I had borrowed money from my mortgage to do it, right? And it was tens of thousands of dollars. I could no longer afford it with the exchange rate, because I was holding a home here. I'd left my wife here, and I'd gone for, I was meant to go for 3 months to the US. And I remember thinking, because I was sitting there looking at all the other, prospective students we sort of met before the start date, and I was thinking, it was so clear to me that the bootcamp environment is one where the entire marketing is around learn to code in 90 days or 120 days or whatever it is, right? And I remember thinking, I don't think you'll ever stop learning to code.
Yeah.
It never ends, and there was this false expectation that after 90 days or 120 days, you'll have these superpowers, and I've never seen that in any career. After 5 years of law school, I did most of my learning on the job. That's just the reality of it. And the same thing when I moved from, into the business side of things, I was thinking, this is a sense of false expectation. Like, it's really good because it keeps you accountable, it gives you structure, you get straight to the finish line, but there is no finish line. It's just that they put one, it's kind of arbitrary. And then like cookies, they just push you through the machine. They race you through it. And everyone who came out the other end were frazzled and stressed and really doubting themselves because they'd moved so fast that they were tactically responding to the course rather than absorbing the material properly. Nothing wrong with that, but it's aimed to get you to an arbitrary finish line really quickly. And these are people who are, in the mid-20s, late 20s, some amount of professional experience, not a lot. And, a lot of them were career changes. And it was quite clear to me that at the end of this process, they were not going to be job ready. It was quite clear to me, no matter what the promises were, they weren't going to be job ready, not because they didn't know coding, but knowing to code is like knowing how to read and write. It doesn't make you an author. Yes. There's much more, to programming than just knowing how to write syntax and how things glue together a little bit. There's a lot more to it. And that's when I realized, okay, this may not be the right model for me, only because it was setting me up with the wrong expectations. And I had to come back to Australia and do all of it, So that's when I invested in a coach. And my coach said, sort of similar things to what you're saying about, knowing the fundamentals. But the coach also said something interesting to me. He's like, why don't you get paid to learn those? Why don't you get your first job in a place that doesn't need these really complicated concepts of computer science, because they're not at that scale, but you're learning to program every day. You're starting to put things into a production environment. You're starting to understand how to wire up a database. You don't need advanced computer science. And he's the first one to say, he said, there's a small difference between a developer and an engineer. A developer will write a lot of code and an engineer will think about the engineering implications of it and write the code, And so you want to go from developer into more of an engineering mindset. You don't need formal qualifications, but it takes time. Don't rush, don't put arbitrary deadlines, learn on the job. That changed my life, Dhaval, to be honest. Just that one piece of guidance, which took weeks of coaching for me to really understand what it meant, it made a huge difference. And I think, I'm open about the fact that at Google, there are days when I really struggle. Not because I don't think I'm good enough. It's because I don't know what everybody else knows with the formal background. I have that extra hurdle that I need to learn. I need to invest. And what you said about the imposter syndrome is so true, 1000% true. Like, you end up doubting yourself. And all you need to remember is if Dhaval can do this today, there was a time when Dhaval couldn't do it. Dhaval learned how to do it. If I can't do it today, it's because I do not know what Dhaval knows. That's all it is. It's a difference in knowledge, which is completely overcomable, surmountable. You just had to acquire that knowledge in a little way, with a little effort, and that changed my mind. So, thank you for sharing that, because I think it's really important for people to know that, which then sort of brings me to, a question that I'm now starting to think about a lot. We were talking earlier about a lot of people wanting to move from traditional software engineering into machine learning and AI. What do you see as being the difference in the content of a role? The average software engineer versus the average ML engineer or AI engineer, data science, data analysis. These boundaries are getting quite blurred now, but conceptually they seem to me, intellectually in my head, they're different buckets. What do you see as the difference in the roles? Because you sat across both worlds.
So the difference between software engineer and ML engineer is same as different between a general physician and a heart specialist. So a heart specialist is someone who knows the general principles of medicine and they have studied the human anatomy and whatnot, right? But in addition to that, they know they're expert in when it comes to heart. Similarly, machine learning engineers, first of all, they need to be a very good software engineers. So they need to know whatever any software engineer, the kind of skills that any software engineer has. In addition, now they need to know machine learning, which is knowing a lot of math and statistics, all the principles behind like data cleaning, feature engineering, building models, deploying models, ML ops, retraining those models, using cloud solutions such as Amazon SageMaker, or Google has a lot of like AI cloud solutions, all of that. So that's how you define the difference in a very like simple 2 lines. When it comes to data scientist and data analyst, those are like totally different. Data scientists, to some extent, they need to know software engineering skills, but not too much in detail. Like they are kind of a weak software engineer. It's okay if you're not too good in data structures and algorithm. But data scientists are more like mini entrepreneurs. They need to know a lot about a business problem. They need to have a lot of business understanding. So forget technology. Technology is one thing, but more than technology, they need to know a lot about business. They need to have a good domain understanding. And then they need to formulate that problem, that business problem. They need to come up with an innovative solution or a data story almost. And in order to come up with that data story, they can use simple BI dashboards which are built in Tableau or Power BI, or they could do predictive modeling using scikit-learn or PyTorch or TensorFlow when it comes to deep learning. And once these models are built, they need to present those findings to stakeholders and kind of convince them of those results. So data scientist is kind of like 50% soft skills and 50% like technical skills, whereas software engineers, they need soft skills, but the kind of weightage that you need to have for technical skill is more when it comes to software engineers. Data analyst is another like a different thing, where data analysts are more like data scientists, but they don't need to know machine learning that much in detail. Data scientist is almost like all the skills that you need to have for data analyst, plus modeling skills, like machine learning skills. So data analysts in their day-to-day life, they would know about SQL, they would know BI tools, they would be good in communication, domain understanding is big. And once you acquire all those skills, you become data analyst. And then on top of that, you become better at programming and you learn machine learning, and then you become data scientist.
That's great. That's fantastic. I think you've explained it much better than I've ever heard anyone else sort of explain it. So it sounds to me then that they're actually fairly different tracks.
Yes.
Right? In which case, I wonder if many people fall into the trap of thinking they're substitutable terms like data science and data analysis are, kind of the same thing. Like it's tempting to think that they are, synonyms of each other or, cover the same thing, but actually it's not, judging by what you're saying, in which case the next question that's popped into my head is that means designing for people who are trying to teach themselves, which is actually quite hard to do, even if you're using, the free information, especially if you're using free information, it's really, really hard because you don't know how to stack your learning.
Yes.
You don't know how to build your and design your own curriculum. And that this means that it's particularly important that you have to have a well-designed curriculum based on your goals. Like if you try to do machine learning stuff without understanding the basics of data analysis, it's possible, of course, anything's possible, but you're probably making it harder, or worse, you're spending a lot of time learning things that you don't need if what you intend to do first is become a data analyst.
Yes, right? Exactly.
Learning skills.
Okay. When you talk about data scientists, like people think it's all about machine learning, but machine learning is in fact a very small part of data scientist job. Machine learning is probably 5%. 95% is something else. And I see so many people who wants to become data scientists, they spend 95% of their time in machine learning and only 5% of time in rest of the things.
Correct.
So it's kind of the reverse, And I see your point about having that guided path almost where you can stack up your learning. And I've made some videos on YouTube, on my YouTube channel. If you go to YouTube and search for Code Basics Data Analyst Roadmap and Code Basics Data Scientist Roadmap, I have at least tried. I know those things are not perfect, but I have at least tried to make those paths where, it's like a 3-month learning curriculum where 2 months you spend in learning Excel or Python and Pandas. You do this much and don't spend too much time on these things, because these things are black holes. Like if you start making yourself a Python expert, it might take you 5 years just to learn Python. You want to become a generalist, you want to become a jack of all trades rather than being an expert in one thing. I mean, that's how you should design career in today's time. So yeah, but I definitely see like a lot of courses, e-learning courses, and I see a humongous disconnect between what you're being taught in those courses and university versus what you actually do in your day-to-day life. I just today posted a LinkedIn post about, Michelangelo, how he painted the ceiling of that Sistine Chapel in Vatican.
Sistine
Chapel,
saw that
right?
post. It was great.
Yeah. So he would like lie back on his back and he would just paint those things and the paint would come on his face. He absolutely hated that job. And when you look at those paintings, you appreciate his creativity. But then if you look at the day-to-day life, there's like a lot of grunt work involved in that. And people don't get that point. If you look at the student
really do not.
who is doing data science master or data science bootcamp, they think, okay, data is prepared for you and you're building this crazy model, you're doing grid search CV, trying to optimize the model, and world looks so beautiful. And when you start working at the real job, like the first problem you face is the data that you deal with is so massive. There are so many quality issues that many times I've seen data scientists would spend so much time in just looking at data, and when they start consuming the data, they find a lot of quality issues. They pass the feedback to software engineer. Now software engineer will spend time in fixing those issues. Sometimes even data scientists help them fix those quality issues. And then, like you're 3 months into your project cycle and you have gotten nowhere. You still don't have your data. And now you spend another 2 months in actually transforming the data, and you have to do further data cleaning, let's say feature engineering. And when it comes to actual model building, I mean, you're just done in like 1 week. So then the mistake that junior programmers or junior data scientists make is they think that, oh, this company is not good. I'm not getting too much exposure in building models, and they leave the company. I've seen this. They leave the company. They say, oh, I'm doing shitty work, but well, everyone else in the world is also doing shitty work. Even big companies like Amazon, Google, and there's a lot of grunt work that you have to go through. So you need to love the process, not the outcome. You have this illusory vision of your amazing data scientist life that I will be building amazing models, but no, you have to do a lot of shitty work.
So true. Oh my God, Dhaval, I hope people hear you on this, because I think this is the most important takeaway from this conversation today, is that everybody who gets into this has some romantic notion in their head. They only see the beautiful end result. They do not see the process, whether it's software engineering, and particularly, in the ML and data science world. The story that you had is exactly what I was actually going to share when I interrupted you. Is again, same thing here I've seen in Australia, where an entire team quit because they were all a bunch of young, gung-ho, enthusiastic data scientists. They were brought in by a very large listed company here. They were doing all kinds of stuff with advanced NLP, using call center data to, do all kinds of fancy stuff and, automate a whole bunch of things and have conversational AI and all that. And the executives thought it was going to be fast. They didn't know what it was, going to happen. And so they had a 12-month timeline to get this done. some 2.5 years later, they still hadn't finished data wrangling because
Yes.
there was so much, there were decades of data. Nobody had thought about that. Their budget overruns. The entire team quit and left saying this is rubbish work. And I remember somebody else in the world here, in the data science and ML world here said, this is actually not shit work. This is the work.
This is the work. Yes.
Is the nature of this is the work. It's not shit work. This is the work, So I really hope people take that on board, because I see that as being a major cause for professional dissatisfaction and disillusionment and quitting needlessly early. So look, I think that was a really valuable, a fantastic conversation. Thank you so much for your time, for sharing all that. And I know you've got a bad throat, so I really appreciate you, stepping up and sharing everything that you know. Anyway, I do want to end on one thing, which is you have invested a great deal of time and effort in making information about engineering, coding, the technical track in life very accessible. And I know from having had many conversations with you over the last few months that your mission is deeply, deeply designed to serve people, to make it possible for them. We now live in a time when there's too much information, and people think that because it's freely available, it's actionable. It's actually gone to the point where you can't. There's too much noise in the system now, And going back to a conversation about the right curriculum design, I think the big advantage here is not getting the information. The big advantage is knowing how to use the information in what order, so that, as you said, people who want to do data science are not spending 95% of their time and energy on something that is only 5% of value to their career. That's a huge problem, especially for career changes. But, do you have anything in terms of future plans that you want to share?
Yep. So I'm working on building some awesome courses right now. So far, YouTube was totally non-commercial initiative for me, but my channel has grown to a level that I'm thinking about, building some high value content in terms of these paid courses. And the way I'm going to build my courses is going to be based on project-based learning. So the first course that I'm building is around learning Python by building a project, basically. So if you look at Python courses out there right now, the first course, the first few chapters, they immediately start teaching you what is variable, okay, what is string, and things like that. In my course, I'm going to start with a problem statement first. So let's say you don't know coding, but you have to solve this real life problem. Now, to solve this problem, how do you use Python? And you will learn only that much Python which is needed to solve this problem. Because to become master at Python, I don't consider myself a master in Python. I've been coding in Python for 8 years. So you have to your focus should not be the tool. Your focus should be the problem. And that's how I'm going to build my courses. So the first course will be out soon, I think probably in the first or second week of January. And then there is another course I'm building on Power BI, which is another project-based learning, So all of my courses are going to be very, very practical project-based learning. And I don't want to fill your head with a lot of knowledge and information. I want to make you an author. I don't want to make you an ordinary typist, who just knows how to type.
Exactly.
But so yes, definitely.
That's fantastic.
I'm going to launch my website and everything. So if anyone is interested, they can follow my YouTube channel. I will make those announcements in a few weeks.
Great. Okay. So that's really good to know, because I think project-based learning is the only way to do it, because people get really caught up in the syntax and all that, and you don't understand why, and you forget it. You don't understand why you're doing it. You forget, so whereas if you go from the top-down method, here's the outcome I want. How do I solve this using these tools? It's an essential way to learn. That I think that's fantastic. Okay. So I look forward to seeing that. I think people will get a ton of value from that. I've got a ton of value from your channel over the years. So, thank you for everything you do. And thank you for taking the time to talk with me today. I really appreciate it, Dhaval. That's wonderful.
Thanks for this awesome conversation, Zubin.
Great. All right. I'll see you soon.
Yeah. Bye.